complex fractions, simply put, they define it as a fraction within a fraction, or potentially a fraction and a negative exponent involved. Now, there are two ways you can do these, and I happen to like method 2, so that is going to be the way I'm going to teach these. If you want to look back at method 1, you can. Obviously, they give those to you. But to me, method 2 just works the best for all cases. So, the two ways you can do it is simplify the numerator, whatever it is, simplify the denominator, and whatever you get then, use it to multiply by the reciprocal, okay, whatever you end up with. That's going to be solution 1, or method 1, all right? Method 2, and that's where I want to take us, is when you're dealing with fractions, once you've gotten everything into a clear fraction form, like if it's a negative exponent, move everything around, you find the lowest common denominator of all the denominators, whether they're up on the top or within the bottom, and you multiply both pieces by that. The reason I like that method best of all is it eliminates the fractions altogether, okay? And then it leaves you with one fraction instead of 2 up here over 2 down here, or whatever the case is, okay? Example 1 is a really simple one. I'm going to go ahead and do something like that for you. The one in the book is already there. It's already laid out. You can see that the greatest common factor of 12, 6, and 9 is 36. So they multiplied everything by 36. Hopefully you're looking in your book on page 239. And that's how they canceled out the denominators of all these fractions. But I'm going to do another example 1. That way you not only have the one that is right there in your textbook, but you also have another one to use. Okay. So what we have is the difference of 3/4 and 1/8 being divided by the sum of 2 and a 12th. Okay? Now, for sake of argument, we're going to think of 2 as a fraction, which makes it 2 over 1. The greatest common, or the lowest common denominator of 8, 4, and 12 looks to me to be 24. Would you agree? So I am going to multiply each piece by that 24. Okay? So think of it as 3/4 times 24 over 1 minus 1/8 times 24 over 1, okay, divided by 2 times 24 over 1 plus 1/12 times 24 over 1. Okay, so do you see how I've inserted the 24 as what I'm going to multiply, and obviously that's going to cross-cancel all those denominators. 24 over 1, 4 and 24 are divisible by 4, so this gives me 6. So in this position, 6 times 3 looks to be 18. 18. 8 and negative 24 are reducible by a factor of 8, gives me 3. 3 times 1 is 3. 18 minus 3. You guys all in agreement with how I have my new numerator? Okay, down below. 24 times 2, there's nothing going on there, so you end up with 48. Positive. 12 and 24 reduced by a fact by 2. 2 times 1 is 2. Okay? It's a whole lot easier to get rid of the fractions and then work the problem than it is to change everything to eighths, add it or subtract it. Change everything down here to twelfths, add it or subtract it. Multiply by the reciprocal. That's too much work. Okay? 18 minus 3 looks like it's 15 over 50. So what, 3/10? If I did my arithmetic correctly? 3/10 is going to be your answer. Okay? again, this is using what they call method 2, okay? It takes less ink, and anything that takes less writing is something that I think is going to be most efficient, so that's where I go. I always go where I can be, where something's most efficient. Okay, example 2, we're going to just go ahead and look at example 2. They don't really give me any good examples for that one. Okay, so I'm just going to do theirs, because they didn't give me an extra example. So here's their example 2, and I'm going to just expand upon what they have there. First common error is to make sure you copied it right. Okay. If you recall when working with fractions, if you have whole numbers, throw a 1 underneath, and by doing so, you've created a fraction version. So z became z over 1. What is the greatest, lowest common denominator of z and 1? Obviously, it's going to be z. Okay? So I'm going to multiply each piece by z. Okay? Okay, so in the first position, z times z, nothing cancels. Here, the z's cancel. Okay, so it's z minus 1 in my numerator position after cleaning it up. I'm sorry, z squared. I forgot to write the 2. Okay? And in the bottom position, z and 1 over 1, nothing cancels. This cancels here, z minus 1. Okay? Now, when you solve these, they want you to solve them, simplify, and make them in the lowest possible terms. So that means you're going to have to factor and reduce where applicable. This is the difference of squares. Z plus 1, z minus 1. Okay? Obviously, you can see that your z minus 1s are going to cancel, leaving you with a final answer of z plus 1. Okay? It's less ink. Less ink. All right, example 3. This is where everybody starts to get nervous, but don't. Okay? Example 3. So we've got negative exponents. A to the negative first minus x to the negative first. All of that is divisible by a to the negative second minus x to the negative second. So the first thing you got to do before you even start thinking about common denominators is clean up those negative exponents. The numerator becomes 1 over a minus 1 over x. I'm not going to write the to the first because it's quite irrelevant here in this case. Okay? The denominator becomes 1 over a squared minus 1 over x squared. Lowest common denominator, a squared, x squared. You guys all see that? Hopefully you do. a2x2, a2x2. And you all might have your own style. This is how I like to do it. You don't have to use different colors. I'm only doing that for you guys. Okay. So let's see if I can do my canceling correctly. One of the a's cancels here, which gives me ax squared in the first position, minus one of the x's cancel, a squared x. Okay? I could factor that, and I will eventually. All of this over the a squareds cancel, x squared. The x squareds cancel. Okay? So, if I look at the numerator in this position here, in this, we've gone on to there, I'm going to pull out ax, x minus a. So this times this is ax squared, this times this is a squared x. Good. So I pulled ax out. Difference of squares here. X plus a, x minus a. Didn't mean to line them up, but it just so happens that's how I ended up. Those cancel, leaving me with ax over x plus a as my answer. Okay? How's that looking for you guys so far? Okay, I gave you 1 through 20 all, and the reason I did that is it's my hope that for every odd you do, that you see you're correct, use it to do your evens. Okay? If I don't see work for the odds, if all I see is answers, I'm not accepting it at all. Okay? I want to see work for everything. There's no way you can solve this without doing some work. All right, my friends, have at it.